Hi there, Algebra 1 students. This lesson, or this video, is for Lesson 8-2, Finding Zeros, which we also call x-intercepts. And so you need to start on page 15 in your note packet. Or if you're watching this video perhaps at home because you were absent and you don't have a note packet, then you can just pause the video and write the problem down. So our steps are written right here. So it says step 1, let f of x equal 0. Remember, f of x is the same as y. So if you find f of x in this equation, it's right here. So the first thing we want to do is replace that f of x with a 0. So instead of f of x equals x squared minus 2x minus 15, we're going to say 0 equals x squared minus 2x minus 15. So the reason that we're doing that is just a little quick reminder. We are finding x-intercepts. They are points on the x-axis. So anytime you have a point on the x-axis, it has an x value, but the y is always going to be 0. This one also would have an x value. In this case, that would be a negative x, but your y is going to be 0. So when we write this equation, we are finding x when y is 0. That is what an x-intercept is. Then it says factor. So we're going to factor this trinomial just like we did in Chapter 7. So when we factored, the first step was find your a, your b, and your c. So be careful with your negatives. A is the coefficient in front of the x squared. B is the coefficient in front of the x, which is negative 2. And c is the coefficient, or the plain old number hanging off the end that doesn't have a variable with it. If you also remember from Chapter 7, when a is 1, that means we do not have to do a box. So when we're factoring a trinomial that has an x squared, an x, and a constant, we typically do x box. But if your a is 1, we can just do our x. So recall, top of the x is a times c, bottom of the x is b. Our a times c is negative 15. Our b is negative 2. So we are looking for two numbers that multiply to give us 15 and add or subtract to give us 2. Well, numbers that multiply to give you 15 are 1 times 15 and 3 times 5. That's actually all there is. If I subtract 5 minus 3, I get 2. Or 3 minus 5, I actually get negative 2. So those are the factors that I want. I know when I multiply them, I need to get a negative 15. So one of these I have to make negative. When I add them, I want my answer to be negative. So I'm going to make the bigger number negative. So negative 5 plus 3 is negative 2. Negative 5 times 3 is negative 15. And then remember, we circled those because those were the important numbers that we were going to use again. Now, normally if we were doing box, we would put those in our box. But if a is 1, we can just write our factors as x plus 3 times x minus 5. So remember, this is the factored form of this trinomial. So we set this trinomial equal to 0, so we want to keep this equal to 0. Remember, our job is to find x when y is 0. Find our input when our output is 0. So we set it equal to 0, and we factored, and now we're going to use ZPP, zero product property, which says if you have two anythings really multiplied together and your answer is 0, so we are multiplying two binomials together, and our answer is 0, which means either our first binomial equals 0, and I'm just going to draw a line here, or our second binomial equals 0. All right, now let's solve for x. Remember, the solution we're going after are x values when y is 0. So to solve this equation for x, we're going to undo addition by minusing 3 from both sides. And we're going to get x equals -3. And to solve this one, we're going to add to undo subtraction, and we're going to get x equals 5. And remember when we were exploring what the factors look like and what our solutions look like? Our factor here had a +3. Our solution is the opposite sign, or a -3. This factor had a -5, and our solution, or our x-intercept, has a +5. So your solutions are -3 and 5. I would also like you, for your notes, to write these two solutions as coordinate points, because those are where your parabola intersects or crosses the x-axis. If you have some room, I would also like you to just do a tiny little sketch. And we want to do 1, 2, 3, 4, 5. Put a point at +5 and put a point at -3. Our a is 1. I put a smiley under there, which is good, because if your a is positive, that means you have an upward facing parabola. So this is really rough because we don't know where the vertex is, but we know that our parabola is upward facing and intersects the x-axis at -3 and 5. So if you need some time, pause the video and get that picture and take a moment to make sure your notes are complete and you have all of that in your notes. We are going to do one more example in this video. So on to number 4, example 4. So same thing. Set it equal to 0, or let f of x equal 0. So that's our first step. So instead of f of x equals 16x squared plus 8x, I'm going to replace this f of x with a 0. Remember, I'm finding where y is 0. So that's why I set my output equal to 0. Okay, we did that. Now we want to factor this. So this has an x squared and an x. It doesn't have a constant hanging off the end. But what I notice right away is this has a GCF. I notice that 8 divides evenly into 8 and to 16. So it has a GCF of 8, and both terms have an x. This term has 2 x's. This term has 1 x. So both terms have at least 1 x. So I have a greatest common factor. So I'm going to factor this not using Xbox. I'm going to factor this using GCF. So both of those factoring techniques that we learned in Chapter 7, we will keep using when we're solving our quadratics. So in Chapter 7, we put what we were factoring in the box. So 8x, so 16x squared, and this is positive 8x. And remember, we said if you have a plus there, you're going to have a plus up there. Outside the box, we put our GCF, which is 8x. So then, what times 8 would get me 16? Well, that would be a 2. I have 2 x's in the box. I have 1 x here, so I need another x. So 8 times 2 is 16. X to the first power times x to the first power is x squared. Okay, that looks good. Now, what times 8x will get me 8x? Well, that's just going to be 1. So in factored form, remember your factors are everything outside the box. So I'm going to write them, I'm going to put them both in parentheses. We'll do it so it's similar to what we do up here. 8x times 2x plus 1, so those are my factors. And remember, this is the same as the binomial we started with. This is in factored form. This was not factored. We had our original binomial set equal to 0, so set your factored form equal to 0. So we factored. Now we have two factors multiplied together that equals 0, so now we can use ZPP, zero product property. Remember, you can't use zero product property unless you have two things multiplied, that's the product, and equal to 0. So the two factors that are multiplied are 8x and 2x plus 1, so I'm going to set both of those equal to 0. And then now I'm on the home stretch. I just have to solve for x. So to get x by itself over here, I need to undo multiplication by dividing. 8 divided by 8 is 1x. 0 divided by 8 is 0. So this is not undefined. If you're confused, put that in your calculator. 0 divided by 8 is 0. So one of my solutions is that x equals 0. That's fine. 0 is a point on the coordinate grid. Okay, now let's solve this one. 2x plus 1, undo addition or subtraction first. Subtract 1 from both sides. Positive 1 and negative 1 make 0. So now I have 2x equals 0 minus 1 is negative 1. Now divide both sides by 2. I'm kind of running out of room here. 2 divided by 2 is 1, so I have 1x equals, I'm just going to leave that negative 1/2. If you want to put it in your calculator and write it as a decimal, that is fine. So this is x equals negative 1/2. Oh, I guess I didn't need to write the x equal. We already had that. So those are my solutions. I'm going to put a quick sketch here. This one's going to be tricky though because these zeros are close together. So I'm going to go all the way over here and say that's negative 1 and this is positive 1. So one of my solutions is at 0, which is at the origin. The other one is at negative 1/2, which would be right between 0 and negative 1. So my other solution will be right there. And this is going to be a really skinny parabola. But that is what it would look like. So just keep in mind, you're finding these 2 points on the graph. This turning point is the vertex. We're actually going to learn how to find that next week. Okay, what I would like you to try now is, turn the page. I would like you to try this U-try that is on page 16. And I would like you to, looking for your practice packet here, when you finish that, I would like you to find your practice packet. Sorry, I had to walk away from the camera for a moment. So the U-try on page 16, and if you finish that, I want you to go to your Chapter 8 practice packet, and I want you to go to 8.2 practice. So this is page 4 and 5, and I would like you to do number 1, number 2, number 3, and number 4. Number 1 through 4. So 1 and 2 you should have notes from yesterday, and then 3 and 4 are just like the examples we just did. This video will also be posted in Google Classroom, so if you feel like you need to watch it again, by all means, watch it again. Thank you.